Great. Welcome to your online session. And today we're doing confidence intervals. Just to recap on what we have done the previous week. Remember, we were doing sampling distribution the previous week, and we looked at how we calculate the probability and how we find the Z values and all that. We're still going to continue with the Z value table that we have used, but we're going to be using some terminologies now. Remember, for the past weekend where we looked at the Z table, we were finding the probability inside the table. Now, with confidence interval, we are going to use the probability inside the table and go outside of the table to go find the Z value. The same way as we did with one example that we use the probability and go find the Z value. So now with confidence interval, when I say a critical value, I mean the Z value. It's one and the same thing. And I'm also going to introduce a new table, which is a T table, when we do some of the exercises as well. So let's get to understand what confidence intervals is all about. So don't look at the times. This is for the other session that I used previously. So we're going to look at the basic concepts of confidence intervals. By the end of today's session, you should know how to construct the confidence interval for the population, for the proportion as well. So when we talk about the confidence interval, we can calculate it for the proportion and we can also calculate it for the mean. And when we calculate it for the mean, and that's where I said I'm going to introduce a new table. When we calculate for the mean, when the population standard deviation is known, we're going to use the Z table to go find the critical value. When the population standard deviation is unknown, it means they give us the sample standard deviation, we're going to use the T table. And for the proportion, we continue with the Z table. So what are confidence intervals? A confidence interval is a process of estimation. In chapter 1, we speak about what the population is, and when the population is big, we take the sample. With a confidence interval, we can use the values from the sample to estimate what the population mean is, so that we can also be able to infer all the results that we get from the sample to the population that we selected the sample from. So remember, when you select the sample, you calculate the mean and you get that the mean is this. But sometimes you also have the population mean. So you need to make sure that that mean for the sample falls within the confidence interval in order for you to be able to infer the results back. And when it does fall within the interval, you should be able to say, I am proudly to say, I am confident that the population mean will be between those two values. Because then you would have calculated the confidence interval and your mean will have been within that confidence interval. If it falls outside of the interval, you cannot infer the results back to the population. To calculate the confidence interval, we use the formula. We use the point estimate plus or minus the critical value times the standard error. The point estimate is your sample statistic value, like your mean, and later on like a sample proportion. So we will use those. Our point estimate will just be your sample statistic that we use to estimate the value of your population parameter. The critical value, like I explained earlier, it is your Z value, or it will be the value you find on the table. So for example, if we go on the Z table, it will be the value on the Z table. If we go on the T table, it will be the value on the T table. And that will be the critical value. The standard error, like we did with the sampling distributions. Remember, in the sampling distribution, because we had the population proportions and the population mean, it was easy, and also took and the population proportions. It was easy to calculate the standard error as well. So here, because we're not given the population parameters, we are going to be using the sample parameters. You will see also when we talk about the standard error, it will be your sample standard deviation divided by the square root of, or divide by the square root of your sample size for the T, and for the where the population standard deviation is given, it will be your population standard deviation divided by the square root of n. And for the proportion, you will see that we use the sample proportion values, the square root of your sample proportion times 1 minus the sample proportion divided by n. And with that, you will be able to calculate your confidence interval. With confidence interval as well, because of that plus or minus there, it tells you something. It tells you that you will have your upper and your lower interval. The lower interval, we always find it by using the minus sign. The plus and the upper interval, we use it by calculating the addition. So that formula on its own, you can split it into two. Because the way this formula is your point estimate minus your critical value times your standard error. And your point estimate plus your critical value times the standard error. And that's how we write the confidence interval. Okay. So because I'm talking about confidence intervals and I'm talking about the critical values, you need to know how to find the critical value. Finding the critical value, since I said the critical value is your Z value from the Z table, and it will be the value from the T table when we find the value there. You need to use the value of alpha. And alpha is called the level of significance. Sometimes they might give you alpha as alpha 0.05, or they might tell you that at confidence interval of 95% find the confidence interval at 95% confidence level. So you need to use the confidence level to derive your alpha, which is your level of significance. I'm gonna do that. Your level of significance will be 1 minus alpha equals to 0.95, where you make alpha the subject of the formula, which will be your level of significance, which then becomes 0.05. With that, you can then go and find the critical value. Now let's learn how to find that critical value. Finding the critical value, which because we're doing lower intervals and upper intervals for the confidence interval, therefore it means we have two sides for the critical value. And since we have two sides, it means our alpha will have to divide it because it has to be distributed in both sides. So we'll divide our alpha by 2 to find the critical value. So if we have to find the critical value of 95, we know that our alpha is 0.05. Therefore, our Z alpha over 2 will be given by Z 0.05 divided by 2, which then gives us Z of 0.025. And I'm going to put a 0 there because when you go to the Z table, your your table has 4 decimals. So to find that critical value, let me just show you on the T table, on the Z table for now. I'm going to keep that and I will go to the table, the Z table, and you will always find it in the negative side of the table. So if I come to the negative side of the table, which is this, I know that, oh, come on. On the table, it has the values on the side, remember, and the values at the top. This is your normal cumulative standardized normal distribution table, table E2. Cumulative standardized normal distribution table. So inside this table, I need to find Z 0,0250 inside the table. So if I look at the values, I can just go through every value to see if I can locate 0,2, 0,250. There is my value. So since I've located it, I will go out of the table and I will go up on the table. And I can see that this value corresponds to 1.9 on the side and 6 at the top. And I'm going to put the plus or minus. It's not necessary, but I'm going to just put plus or minus because then we have both sides covered. And that will be my critical value on the Z table. Going back to the slide, we know that our Z value is 1,196. So therefore on the, it's plus or minus. So on the left side, on the lower interval, we have minus 1.96. And on the upper interval, we will have 1,96. And that's all what you need to know about the critical value. So we're going to use this critical value to calculate the confidence interval. So let's say, for example, this is an exercise that I need to do, but I'm going to do A and I'm going to do B, you're going to do C. And then we can answer the question. So consider the random variable X with the mean of 100 and the population standard deviation of, gosh, it didn't copy everything. I'm missing my population standard deviation on this exercise. Okay, I will have to go back to, because I got it from your tutorial letter. Let's go to the tutorial letter and get the right question. Okay, we'll work it out from there as well. Okay, of 9, standard deviation of 9. So I'm just going to work it out from here. So I'm not gonna close it anymore. So I'm going to do number 1. So remember the formula is point estimate. Our formula is point estimate plus or minus our critical value and times the standard error, if you remember very well. So since here we're using the population standard deviation is known, and just for the critical value, I'm going to use the 95% confidence interval. So our point estimate in this instance, it will be our sample mean of 100. So it will be 100 plus or minus our critical value. We did find the critical value. Remember, we went to the table. Our Z alpha divided by 2 was plus or minus 1.96. So I don't have to repeat the plus or minus because it's already there. So this will be 1.96. Multiply that with the standard error. Remember now, because I'm using the population standard deviations. So this will be the population standard deviation of 9 over the square root of the sample size of 30. So, and that is how you're going to use your critical value in the formula. I don't want you to calculate as yet. We will come back and do the calculation later on. I just wanted to show you how the critical value will work. So sometimes your critical values might be different. So let's say, for example, for some of the common critical values, you might have, for example, don't look at that, it's the confidence levels. So they give you a 90% confidence level. So if you go to the table, you will see that it will be 1.465. Why is it 1.465? I'll show you now on the table. So if we go to the table, for 90%, I'm going to do it here. So for 90%, the alpha value will be equals to 0.10. So therefore, Z of 0.10 divided by 2 will be the same as our Z 10 divided by 2 is 0.05. 0.05. So if I come to the table here, inside the table, I'm looking for a value that is 0.05 inside the table. 0.0, yeah, I have 0.052, this I have 0.51, and I have 0.54. All of them, they are one deviation away from 0.5. So if I add 1 here, I will have 0.5. If I subtract 1 from 0.001 from here, I round it down, I will get 0.05. So between the two, there are almost one standard deviation each either way, whether I round up or I round down. Whether I round up or I round down, I will still get 0.05. So since there is no clear distinction between the two, we use both of the values. Sorry, I'm on the wrong one. This is 0.0. Oh, yes, I'm on the wrong one. So I need to look for 0, oh, sorry, it's this one. I'm on the wrong one. So this is the 0.05, not that one. So also, if you look at this one, it still works the same, because if I look at this, if I go with 0.05, this is 0.051, and if I add on this side as well, it will say 0.049. So it means I can round it up as well there. So there is no clear distinction here as well. So it's either we use both of the values. So if I go out, I have 1.6, but then when I go up, I use 4.5. And that's the only exception that you will have. For 10% or 90% confidence intervals, we use 1.645. You will always use that. So it means on the question, on this one, when you come and answer this question, if it was given in the exam like this, therefore it means for this one, you will use, your critical value will be 1.645. Since we know this one is 1.96. And for the 99%, your critical value will be 2.58. You can calculate that and go find it on the critical, but sometimes it's easy if you know them. But the more you use them, the more you will know what the values are. Usually, the most used value is the 95%. So then it means you will always constantly use 1.96. 0.96. Okay, so how do we then find the critical value on the T table? On the T table, similar. So let's say the T table, they give you a different values. But on the T table, we use T alpha over 2, and we also have a degree of freedom. And we have a degrees of freedom, which is n minus 1. So since on the T table, what they would have done is they would have given us the sample standard deviation. We know that we're going to use the T table and we have the n. So let's say, for example, on this one, let's use n is 5. Let's say n is 5. So we go find the critical value. Our T alpha of 0.05 divided by 2, and our degrees of freedom of 5 minus 1. Therefore, our T will be 0.0250, and 4 is our degrees of freedom. So we need to go to the T table. Go into the T table. You will find a table. It will be just after this one. It will be called T, critical values of T. And on the critical values of T, what you're going to do is you're going to ignore what is at the top, the cumulative probabilities. We're not using that. You're only going to use the upper tail area critical values and your degrees of freedom here. Remember, we're looking for T 0.0250 and our degrees of freedom of 4. So we're going to go to the degrees of freedom of 4 and we go look for 0.025 at the top where they meet. That will be your critical value. So it works different. Remember, with the Z, we go inside the table and we go outside. With the critical values of T, we start with the values at the top and the values of the degrees of freedom, and we go find the critical values inside the table. So you need to remember that as well. So then it means when we do the calculation, our critical value will just be multiplied by that. So our point estimate plus or minus our critical value of 2,7764. And that's how we use them to answer the questions. Okay, come back. So for example, with this one, okay, it's the same thing that I just did. So we are given n is equals to 3. We find the degrees of freedom, which is 3 minus 1, which gives us 2, and our alpha of 0.1. Then it's alpha divided by 2 will be 0.05. So we go to the degrees of freedom of 2 and alpha over 2 of 0.05 where they meet. That will be the value we find on the table. Okay, I'm not going to ask you to do the calculations as yet. So now, since we have learned how to do all those, let's then apply the concept we have learned and calculate the confidence intervals. So to start with, we're going to start with where the population standard deviation is known. Therefore, it means they would have given you the population standard deviation, and when we go find the critical value, we'll go to the Z table. If the population standard deviation is known, we go to the Z table. Okay, there are several assumptions that needs to be met before you can say you are calculating the confidence interval in terms of this. But this is just for you to know the theory behind the confidence intervals as well. So the population standard deviation needs to be known. Your population needs to be normally distributed. And if your population is not normal, your sample size should be larger than 30. To calculate the confidence interval, we use the point estimate in this instance because we're calculating the confidence interval for the mean. Our point estimate will be the sample mean. Plus or minus the critical value, since we're using the Z, it's Z alpha divided by 2 times the standard error, which will be the population standard deviation divided by the square root of the sample size. And all this information, except the critical value, they will be giving you in the statement that you're going to be solving. So let's look at an example. A sample of 11 circuits from a large normal population has the mean resistance of 2.0. We know from the past testing that the population standard deviation is 0.35, and they mentioned it. Population standard deviation, so that you know which one you are working with. Determine a 95% confidence interval. So they give us a 95% confidence interval. So it means we're going to have to find alpha. For the true mean resistance of this population, we know the formula. It's x bar plus or minus the value times the standard error. We've calculated, or we went and found the 95% confidence interval. So I'm not going to go and show you again how to find that, which is alpha divided by 2. Our alpha is 0.05 divided by 2. You go to the table, it will be 1.96. You substitute the values. Our mean resistance from the sample of 11, the mean resistance, which is the critical value, 1.96. Standard deviation, they told us the population standard deviation is 0.35 divided by the square root of the sample size, which is, and you solve the values after the plus or minus. 0.35 divided by the square root of 11 multiplied by 1.96 gives us 0.2068. We split the two. Before I show you the answer, we split the 2 in terms of 2.20 minus 0.2068. And we also say 2.20 plus 0.2068. And when we have the answer, we just solve the one side and solve the other side. And this is our lower interval, and this is our upper interval. Sometimes in the exam, they might ask you to calculate only the upper side. So it means you just do the addition 1. If they ask you for the lower side, you just do the negative side 1. And that's it. And that's how you find the confidence intervals. And to interpret, if you want to interpret, you can say, we are 95% confident that the true mean resistance is between 1.9932 and 2.4068. And that, you have an exercise to do. You work at an airline company and want to find out the mean time in minutes taken by DC-8 to fly from Amsterdam to Paris. The mean flight is important for planning of the arrival and departure time. A random sample of 10 flights. So our N in this instance is 10. Our random sample of 10 flights from Amsterdam to Paris yield realize the sample mean of 40 minutes. So our X bar is 40 minutes. Assume that the population distribution of the flight time from Amsterdam to Paris is normally distributed with the mean and the standard deviation, and they give us the population standard deviation. So here they didn't mention population, but they say the population distribution of with the mean and the standard deviation. But lucky enough, they put there the sigma so that you don't get lost. And you can see that the minute they put the sigma there, then it means it's the population standard deviation. Even if they didn't mention that, we know that it comes from the population distribution. So therefore, it means it was the population standard deviation that they gave you. Determine a 95% confidence interval. So that's your exercise, plus or minus your critical value, alpha divided by 2. At 95% confidence interval, by now you should know that it's 1,96, your critical value, times the standard error. That's your exercise. And when you have the answers, you can just post them on the chat. Are we doing? Are we winning? Hello, talk to me, guys. Or am I talking to myself? Maybe my mic is muted. Who knows?
We're still trying.
Okay, who wants to try this? I don't have a calculator with me. So I will rely on you to give me the answers. The mean, we know that it's 40, plus or minus the critical value of 1,96 times the standard error of 3 over the square root of our n is 10. So who wants to give me answers? So are you telling me, all of you haven't worked it out?
No, I'm not clear what I do with the Z. So I've got the alpha divided by 2.
What do you mean you're not clear what to do with the Z? Remember, Z alpha divided by 2 is Z 0,05 divided by 2, which is Z of 0,0250, which when we go to the table, this whole thing, the Z is just 1,96. This whole Z is just that value, 1,96.
Okay, I've got it now. Thanks.
Okay, my answer is 38.1406 and 41.8594.
Yeah, but I want to write step by step.
Okay, the following step after 40 plus minus 1.96 into 3 over square root of 10 is 40 plus minus 1.8594.
40 plus
1.8594. That is the product of the two.
Okay, so then we split it. Thank you.
I said 40 minus 1.8594. And on the other side is 40 plus 1.8594. Then I got 38.1406 and 41.8594.
And that's how you find the confidence intervals.
Okay.
I'm not going to ask you to do the following one or even that one. We're going to go straight into the confidence interval where the population standard deviation is not given. So when the population standard deviation is unknown, it means they give us the sample standard deviation. With that as well, there are some couple of assumptions that needs to happen. So we know when the population standard deviation not given, we're given the sample standard deviation, which is the sample parameter, the sample statistic S. Since with the sample, if the population is standard deviation is unknown, it means we have the sample information only, then that brings the uncertainty within the calculations that we do or even the result that we have. And that is why for us to make sure that we apply the same principles as well is to use the data that we have, but the data needs to be, or your sample size needs to be bigger than, needs to be big, and the population needs to be normally distributed as well. And for that, we're going to use the T table, which we call the T distribution as well. So the following assumptions needs to be met. Some of them I've just said it. So the population standard deviation will be unknown, but the population needs to be normally distributed. And if the sample size is not, and the population is not normal, the sample size needs to be big, so that then we remove those uncertainties within the data set as well. And then we're going to use the T distribution, which is the T table. to go find our critical value. To calculate the confidence interval, we use the point estimate plus or minus the critical value. And in this instance, because it's the critical values of T, it has T alpha divided by 2 and the degrees of freedom. And our degrees of freedom is N minus 1. Our degrees of freedom is N minus 1 times the standard error. Since we are not given the population standard deviation, we are given the sample, so it will be S divided by the square root of N. Let's look at an example. If I have a random sample of N is equals to 25 and the sample mean of 50 and the sample standard deviation of 8, and I want to form a 95% confidence interval, I can calculate the degrees of freedom, and then go find the critical value on the table. So remember, our degrees of freedom is 24, our T alpha, because it's 95%, our alpha will be 0.05. Alpha 0.05 divided by 2 gives us 0.25. And if we go to the table, if we go to the T table, we look for 0.025 and we look for the degrees of freedom of 24 and where they meet at that point. And that will be our critical value of 2.0639. And that is our critical value that we're going to be using. And that is our critical value. So go to the confidence interval, our mean plus or minus our critical value times the standard error. Our mean is 50. Critical value 2.0639. Our S is 8. Our N is 25. Substitute into the formula and then calculate. And we will find that the confidence interval is between 46, our population mean is between 46,698 and 53,302. And that's how so the same calculation works the same, almost the same, with whether the population standard deviation is given or not. So we will still work it out the same way. With that, there is your exercise. Nope, not that. This is your exercise. That is a 0.92. A random sample of 40 regions, which means our N is 40, gave a sample mean of X bar is equals to 6.88 per kilogram. So our mean is 688. Assume that a sample standard deviation, so they tell us that our sample standard deviation is 1.92. What is the critical value? So you need to go find the critical value at 95% confidence interval. What they're asking you to go find is T alpha divided by 2 and degrees of freedom of N minus 1. The other information are just additional information for maybe the next question. So now you only need to go find the critical value. It should be easy and quick to find. Remember, they give you a 95% confidence interval, therefore your alpha will be 0.05 is your alpha. And what do you have? T 0.05 over 2 and the degrees of freedom of 40 minus 1, which will be T of 0.0250 and 39. Did you manage to get 39 on the
Yes.
T table? And what is the critical value?
2.023.
2.023. With that, I'm not going to ask you to do any calculations as yet, but maybe I should. So if we go back to your assignment, I'm going to ask you to do your own assignment. Easy that way. So on your assignment 3, because we're busy with assignment 3. There is your statement. We're only going to do question number 3, only question number 3. The number of times the AI algorithm is successfully detecting fake news is normally distributed with the mean of 900, and the sample standard deviation of 8. Assume that the sample size is 100. Calculate a 95% confidence interval. So they have given you your X bar, which is 900. They have given you your standard deviation, but the sample standard deviation, which is S, which is 30. They also give you your N, which is 100. They say at 95% confidence interval, so it means our alpha is 0.05. The first thing we need to do is go find the critical value. It's not 1.96. You need to go find the critical value by using T alpha divided by 2 and the degrees of freedom of N minus 1. Now you must remember it's 100. N is 100. So our N will be 99. Let's see if we can get it on here. N will be 99. It exists on the table, so you should be able to find it on the table. Come on. Question 3. So you should be able to go find it on the table. Then you go, after you find your critical value, you must come and calculate T alpha divided by 2 and the degrees of freedom, and S divided by the square root of N.
calculator.
Yes. Oh gosh. Are you winning? How are we doing, guys? Are we winning?
Yes.
Okay, let's see. Substituting into the formula, we have 900 plus or minus. Did you go find the critical value?
Yes. It's 1.9842.
1.9.
842.
842 times the standard deviation of
30.
divided by the square root of
100.
100, which then, if you calculate everything on the right hand side of the plus or minus,
It will be 900 plus minus 5.9526.
and you can then just split it in terms of the minus and the plus, the lower interval and the upper interval. 900 plus 5.9526. You can go find the answer. I'm not going to give you the answer.
Okay.
Can you through up until there? So you will see which one is the correct answer and answer that. So you should be able to also do question 4 and answer some of these questions. And question 5, 6, you should be able to answer question 6 as well. Now let's look at proportions so that you can answer question 7 and going forward. Okay, proportions. So when we work out the confidence interval for the proportion, we're going to use the Z table. We're going to go back to the Z table. And with the proportion, the formula is the point estimate, which will be your sample proportion time plus or minus. Your critical value will be the Z alpha divided by 2. It's always going to be Z alpha divided by 2 times the standard error, which, because in this instance, we are given the sample, statistics. So we're going to use the sample proportion times 1 minus the sample proportion divided by N. Okay, I can just do all of it. So, for example, a random sample of 100 people shows that 25 are left-handed, form a 95% confidence interval for the true mean of left-handers. Same as what we did with the proportion when we were doing the sampling distribution. If they don't give you P, you can calculate P by saying your observation satisfying your sample divided by the sample size. In this instance, our P is 25 divided by 100. And that's what I have done there by substituting it, which it is equal to 0.25. So on this side, our P is 0.0, our P is 0.25 plus or minus 95. So all this 25 divided by 100 is 0.25. Plus or minus the square root of calculating the standard error, which is 0.25 times 1 minus 0.25, which gives us 0.75, divided by n, which is 100. If we solve everything in the square root, we get 0.0433 multiplied by 1.96, and then we do 0.25 minus the answer for this, and we also do the same 0.25 plus the answer for 1.96 times 0.0433, we get 0.1651 and 0.3349. Same method of calculations, is just that with the proportion, you need to know the formula and we need to go to the Z table. And we know when it's a Z table at 95% confidence interval, it's 96. With that, I just want to give you, do one exercise, and then we can see if we can look at your assignment. So if a random sample was taken of 120 employees, so we are told what our N is 120, to determine whether they will support the owner's proposal for participating in a preferred provider plan. Of the 50 employees sampled, this is our 120 employees, which is our population, 120. Of the 50 employees sampled, so this is our N of 50 sampled, 28 strongly supported the plan. So this is our X. Our X is 28. Calculate at 95% confidence interval, our alpha is 0.05. Therefore, our Z alpha divided by 2 will be 1.96, because at this point I know what my alpha is and I know my critical value for 95% confidence interval. Now, point estimate plus or minus our critical value, Z alpha divided by 2 times the square root of point estimate, 1 minus the sample proportion divided by N. I know what my P is because I can calculate my P will be X over N, and my X is 28 and my N is 50. And therefore, I don't have a calculator. Please calculate.
0.56.
0.56. So this will be 0.56 plus or minus 1.96, which is my critical value, times the square root of 0.56, 1 minus 0.56, divide by N of 50. Calculating what is inside the bracket, and after taking out the square root, 1 minus 0.56 equals 0.44 times 0.56 equals 0.2464 divided by 50 equals 0.00498. And that's where I get stuck, because it does not have a square root on it. So when I'm using my phone. You will have to calculate that and tell me how much you get. 0.56 plus or minus 1.96. What do you get from the square root? Actually, I do have a calculator. Why am I suffering? We can go to the desktop. Okay. So we have 1 minus 0.56 equals times 0.56 equals divide by 50 equals, and I must take the square root of the answer. The square root of my answer is equals to 0.0070, some odd number there. Okay, 0.0702. I'm gonna add it off there and say 2 because I just want to write it. Can only write it if it's in presentation mode. 0.07. Now I forgot the values. Keep. And the calculator is gone. I have 2 now open. 702. Okay. 702. Okay. And then I must multiply this by 1.96 and I get 0.13759. 0.137, let's keep it 76. Oh. And 0.56 minus 0.1356. And I do the same this side, 0.56 plus 0.1356. And if I solve this, it becomes minus 0.1356 equals 0.424. 0.4244. And I do the same on the other side, 56 plus 0.1356 equals 0.69. Did I do it right? 0.6956. I don't have the answer from here. It looks like that would have been the correct one, but I am not sure now. Okay, so with that, I'm gonna give you an exercise.
Ma'am, I think you made a mistake when you calculated 1.96 times 0.0702. Answer is 0.1376.
Okay, that's why those calculators were 1, 0,
96. It's 0.1376.
0.1376.
Yes.
Oh, yes, I wrote it all wrong on here. 0.1376. Sorry, my bad. It's me writing it all wrong there. So let's write them correctly. 0.56 minus 0.1376. Yay, it's 0.42224. And on the other side is 0.56 plus 0.1376, which is 0, but I still get 0.6976. What am I doing wrong? Point 0.56 plus 0.1376 is 0.6976. It's not me, it's them.
I get the same answer.
Yes, not me, it's them. Let's blame it on them. Okay, so your last exercise will be from your assignment. And then in front of you, exercise 7. Suppose we take a sample of 200 Facebook profiles and we found only 34 to be ghost profile. What is the confidence, or what is 95% confidence for the proportion of Facebook ghost profile? They've given you your sample size N, which is 200. They've told you what your X is, which is 34. You just need to calculate your P, which is X over N. They've given you your 95% confidence interval. Therefore, it means you know what your alpha value is. It's 0.05. Otherwise, since you're going to find critical value of alpha divided by 2, which is always 1.96. And I told you, they like using 95% confidence interval. So if you don't get it by now, you need to know it, that it's 95%. For 95% confidence interval, the critical value is 1.96. Then you need to go calculate plus or minus your critical value alpha divided by 2 times the standard error, P1 minus P divided by N. And with that, it will complete our session for today.
So tomorrow we do hypothesis testing.
Yes, tomorrow we'll do hypothesis testing. I've split it into 2. So we were going to do it also on a Friday next week. But tomorrow we will finish all hypothesis testing. So we will do all of them. If you understand what we're doing today in terms of the 3 components, where the population standard deviation is known, where the population standard deviation is unknown, and with the proportion, we're still going to continue with that when we do the confidence interval, but we're introducing new concepts as well. So yeah, come ready for that session as well. They'll be intense like we have now. I wish, yeah. But you will manage because we will do lots of exercises and I will use more examples so that you get to understand what you need to do in your assignment as well. Okay, are you winning?
Slowly.
Yes.
Done.
Okay, I'll give them 1 more minute. Okay, let's see how we answer this question. Did you calculate your P? What is P?
0.17.
0.17. Plus or minus critical value is 1.96 times the square root of 0.17 times 1 minus 0.17 divide by our n 200. Okay, when you calculate everything on the left, on the right, what do you get?
0.052.
0.052. Can we leave it at 4 decimal? Because the answer is required to be at 4 decimals. 0.0.
0.0521.
521. 0.17 minus 0.0521 and 0.17 plus 0.0521. And what do you get?
Zero comma 1179.
I think you rounded off somewhere too quickly. You see, when we round off too quickly, we're not gonna find the answer we're looking for. So I will suggest that every time you do these exercises, keep all the digits, especially when you do the one inside, you keep all the digits, and when you come to the 196 as well, you keep all the digits. Because now this is 0.1179, and on the other side, 0.17 minus 0.051 plus 0.0521. 0.0521 gives 0.2221. And if you look there, you will choose none of the above because you won't, there is no answer that is exactly the same as the one that you have in front of you. So please make sure when you do the calculations, you keep all the decimals. So let's look at this. Let me reduce this one a little bit, make it smaller. Since I didn't open my other, can I close the memory or wherever the thing is there? Okay.
I took the entire thing on my calculator and still get the same answer. Like I
Still
took
get the same
exactly
answer.
with the square root, everything. I took it into the calculator and still get that.
Okay, so let me just see here. 1 minus 0.17 equals 0.83. Multiply that with 0.17 equals, and divide that by 200 equals, take the square root of it and multiply that with 1.96 equals 0.05206 007. Yeah, I see that. I'm gonna take a copy of this while we're still on the air. I'm gonna include your picture. I'll send this to your lecture as well. I think probably there is an errata somewhere there. And there was nothing communicated to you guys about that assignment as well, ne?
Not that I know of.
Yeah, no, it's fine. Then I will follow up on that one. But that's how you answer the question. Otherwise, I will send a message on WhatsApp, or I will post it on my UNISA. Okay, so, and that concludes today's session, actually. We right on time. So let's just recap and close off the session. Well, so far what we've learned under the confidence interval, that there are 3 ways to calculate the confidence interval, where the confidence interval for the mean when the population standard deviation is known, we use the Z table. And when the population standard deviation is unknown, we use the T table. And then when it is for the proportion, we use the Z table. Then we also learned how to find the critical values for each one of them. Critical value for the Z, critical value for the T. So for Z table, the critical value, we will find it by using the value or the probabilities inside the table and going outside to look for the Z values. And remember, there is, for 90%, there is an exception, because for that, the critical value will have 3 digits, which will be 1,645. The rest, you are able to find them easily on the table as well. For the T critical value, we use T alpha divided by 2, and the degrees of freedom, and the degrees of freedom is n minus 1. Once you have that, you go to the T table, you will find the degrees of freedom on your left and at the top. Remember, when you read the T table, do not read the values that corresponds to the cumulative area. You read the values that corresponds to the upper tail area, the one closer to the table. And those are the values we use to find the critical value. And the value inside the table, that will be your critical value. And to calculate the confidence interval, which has 2 sides, the upper tail area and the lower tail area, we use the point estimate plus or minus the critical value times the standard error. And that's what we've learned today. And with all that, you should be able to answer your assignment question from question number 1 up to question number 8. Up to question number 8, you should be able to answer all that with today's session. So it means don't wait until the next time you need to submit the assignment, so you can go and calculate question number 8 from 1 up until 8. So we already did at least 2 of them. So your workload has been reduced. And then tomorrow we do confidence interval. So tomorrow you should be able to answer question number 9 till question number 11. Then on the following week, we should be done, because we then do chi-square, and then you are done with all your assignments. Then we concentrate on the exam. For your assignment, you don't do linear regression, but for your exam, you are required to know what linear regression is about. So we will do that as well for your exam. And with that, let me not waste all your time. See you tomorrow.
Thank you.
Thank you.
Thank you. Bye.
Thank you.
Bye.